Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, and in this session we'll be discussing in our HSM modular the option of parallel cuts. We'll start off with our operation of HSS and we'll choose our first area of parallel cuts. We'll choose our linear option. Now what I'd like to do with this linear option in my geometry is to actually work on this surface over here. So I'll go to my drive surface and simply click on the surface itself, and you note that it took the entire surface over here. Now, one thing that's important to know when you're choosing your surface option is that you always have to know if the direction of the surface is going in the right direction that you want, right side of the part of the surface that you want to have it machined. To check this, all you have to do is simply click on Show Direction for selected faces. If I click on it, you'll see that the direction is going towards the top. Sometimes when you get imported parts with different surfaces, you may have problems where the surface is actually going in the opposite direction. So you may have to flip that to the other direction. By the way, flipping to the other direction is simply done by right-clicking on the direction over here and just say simply reverse. But in this case, I do not have to do it because it's going in the right direction. Now, since I only want to work on this surface over here, I'll simply choose my 2D boundary. And in my 2D boundary, I'll choose the geometry that I need to work on, which is this surface over here only. Now, the next thing I must do is choose the tool. The tool that I will be using will be a 10mm bullnose tool with a 1mm radius on the corner itself. Now in my levels, I'll be going back in the Z direction, and in my toolpath parameters, I'll be changing my maximum step over to 3mm each time it steps over. Now I'll stop at this point for a moment and do a simple save and calculate, and we'll take a look at the results that we got from our toolpath. If I use my simulation and run my simulation, you'll note that my toolpath, looking from the side over here, you'll see that it went exactly over the surface exactly like I wanted to. However, you'll note that there are these slots over here that jumps over up on top of it, these holes as well, and I prefer actually going straight over it. Not only that, I would like to work not in this direction as you see here, but rather going along the length of the part itself. So to change that, I'll simply go out of my simulation, and if I go back to my geometry, I can change my define angle by, change it to 90 degrees. In addition now, to take care of the areas that I have to jump over, I'll simply go into my link area. Now in my link area where I have my small gaps along my toolpath, that is already direct, but my larger gaps, I'll change that to direct as well. Now the same thing with my link between slices. In my large moves, I'll also have that as direct. Now when I do my save and calculate, now if I take a look at my simulation now, you'll note that my toolpath is going across the part, going directly over the slots that I have here and over the holes that I have here. There's one thing though I would like to change. You'll note that my lead in and lead out is going directly onto the part. I'd like to rather have that with a curve going down onto the part itself. So what I'll do is I'll go into my link area, and you'll note from the clearance area, my first entry, my last entry, I'll have my lead in using the lead in option, and the same thing with my lead out using the lead in option. Now choosing the default, and the default in this particular case is tangential arc. What I'd like to have it do is actually use vertical tangent going from the top going in, and I'll have my lead out doing the exact same thing. Now if I do my save and calculate and run my simulation on the part itself, you'll note that my lead in now is going in an arc, and my lead on is also leaving in a vertical arc as well. Now in my next operation, I'd like to work on these surfaces over here. To do that, I will use my parallel cuts with the Z option. So I'll simply start a new operation of HSS, and I'll choose parallel cuts with constant Z. Now the geometry, in this particular case, my drive surfaces will be these three surfaces. This one, and this one as well. Don't forget, always take a look at your direction for your surfaces. I'll simply say OK. Now when I go down to choose my tool, I'll use the exact same tool I used before, which was my 10mm bullnose tool with the 1mm radius on the corner. My levels will be exactly the same way it was before. Now my toolpath parameters, I'll change my maximum step over to 2mm. And now again, I'll run my save and calculate. Now this time again, when you look at my simulation, you'll see that my toolpaths will go across, again jumping over these areas over here, but I do not want to actually do that. I prefer going straight over. So what I'll do is, again, I'll go back into my link area. I'll have my large gaps at direct, and this time I'll have my large moves, I'd have them at a blend spline. When it gets to the end, I'd actually rather have it blend in instead of going direct. In addition, I'll also add in my use lead in and lead out for my part, and this time I'll have my default as tangential arc. Now when I do my save and calculate and run my simulation, you'll see my toolpath will go exactly across the part itself, curving in and then curving out as we leave the part itself. The next option I'd like to show is our hatch option of parallel cuts. Our hatch option is used when we have multiple surfaces, including an attached surface over here, where on one surface I want to go in one particular direction, but the other surface I'd like to go in a different direction. This is automatically noticed by the parallel cuts when using the hatch option. I'll start a new operation of HSS, and I'll choose my parallel cuts together with hatch. Now this geometry in this particular case will be the following surfaces: this surface, this surface, this surface, now the attached surface, and this bottom surface over here as well. In other words, I have these 5 surfaces all going in the proper direction as shown here. Now I'll choose again my tool being my 10mm bullnose tool. My levels will be the same. My toolpath parameters, I'll have my maximum step over again at 2mm. Now when I go into my links, I'll have, from using the lead in and using the lead out, I will also have my small gaps direct, and my links between my slices will be at the blend spline option. Now we should note one thing in our geometry, that we have a defined angle of our hatch at 45 degrees. Let's take a look exactly what happens when we have that set at that value. When I do save and calculate and run my simulation, you'll note that my toolpath, and if I look at the top view of the part itself, you'll note that it's going in 45 degrees on the surface, but on the side itself, it's going in the constant Z fashion. Now, if I were to change this value to say 20 degrees and then do save and calculate, you'll note in my simulation that my toolpath, when I look again in my top view, this time it's going 20 degrees across rather than 45 that it went last time, and again on the side it's going according to the constant Z. Thank you for joining us on SolidCAM Professor. Take care and have a nice day.